Unit 6, Lesson 5, the law of sines and law of cosines. Your objectives for this lesson are to use the law of sines to solve problems and to use the law of cosines to solve problems. And just your fair warning here, I know that we've had a lot of difficult things in this unit already. We had geometric mean and angles of elevation and depression, but this is what I think is the most difficult topic in this unit. So law of sines and law of cosines are difficult. Please prepare yourself. The law of sines is this right here. Basically, it tells you that the ratio between a side and the angle opposite it is constant in the triangle. So sine of big A, and remember, big letters stand for angles, sine of big A divided by little a equals sine of big B divided by little b, which is equal to sine big C divided by little c. You might also see this written flipped over. So little a over sine A equals little b over sine B equals little c over sine C. This is the same thing, and that's fine. So you do need to memorize either what's written here typed or what I just hand wrote. You need to memorize one of those. That is the law of sines. What's awesome about the law of sines is that it can be used with oblique triangles. Oblique triangles are triangles that are not right triangles. So before with SOHCAHTOA, you could only use those with right triangles, but you're not always going to have a right triangle. So when you can't use SOHCAHTOA, you can use the law of sines. Okay, example 1, we want to find little b, and we're going to round our answer to the nearest tenth. So remember the law of sines. So sine A over little a equals sine B over little b equals sine C over little c. And we do have 1, 2, 3 ratios written here. But to solve a proportion, you know that you usually only have 2. So even though we have A, B, and C here, at any given time, you're only going to choose 2 of them to use. And even if this is not labeled A, B, C, you can still set up a proportion. So I have an angle in the side opposite it, and another angle in the side opposite of it. That's what I'm looking for. So I can say sine 45 degrees divided by, what side goes with 45 degrees? 30. So divide by 30 equals sine 74 degrees divide by, B goes with 74. Now we're going to cross multiply and divide. So B equals 30 times sine 74 degrees divided by sine 45 degrees. Okay, and let's pull up the calculator. Make sure that we are in degree mode. Good. 30 sine 74, close parentheses, divide by sine 45 equals 40.783. So to the nearest tenth, we're going to have 40.8. So B is approximately 40.8. Example 2, find D. Round to the nearest tenth. Okay, so in this case, I have 82 goes with D. But what about my only other side I have is 24, and there's nothing written for E. Okay, well, that's okay. We can handle that. I have this other angle, 40-degree angle. So I can say 180 minus 82 plus 40. This is going to give me E. Remember, there's 180 degrees in a triangle, so I can always subtract the other two to get the third one. This is 122. So E is 58 degrees. Okay. Now I can set up my proportion. So notice here I have D, E, and F, not A, B, and C. That's okay. But I'm still going to have sine of one angle, so 58, divided by the side that goes with it is 24, equals sine 82 divided by D. Cross multiply and divide. So D equals 24 times sine 82 divided by sine 58. Okay. So D, oh gosh. Just plugging this into the calculator, remembering to close your parentheses. We have 28.0 is to the nearest tenth, so 28.0. Okay. The law of cosines. So this is longer. You can see there are 3 parts to the law of cosines. And let's just look at the first part first so you're not too overwhelmed. Okay, so we have a squared, so that's one side squared, equals b squared plus c squared. That's the sum of the other 2 sides squared, minus 2bc cosine A. And I like to think of this as every letter is appearing twice. The last letter and the first letter are the same. And yes, so everything else is small, lowercase. So little a, big A at the end. And it's a 2, those are squared, so 2 is the only number you should have there. If you look at the other versions, you can see here A and B have switched places. And the last one, from the second to the third, B and C switched places. Okay, and again, this can be used with oblique triangles. Okay, example 3, find C in round to the nearest tenth. So we're looking for little c. So since we're looking for little c, you're going to put the small letter that you're looking for on the left side of the equal sign. So we're going to use c squared equals a squared plus b squared minus 2ab cosine c. And we're going to plug in what we have. If you didn't have an A, B, and a C here, again, if you're looking for the side, that's what you put over on the left side here. The other 2 sides are what go in for A and B. So c squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times cosine 48 degrees. You can put this all in to your calculator at once, but there's a lot of stuff here. You might mess it up entering it in, so I'm going to suggest that you simplify it a little bit first. 12 squared is 144. 10 squared is 100. And 2 times 12 times 10 is 240. Okay, so c squared is 244 minus 240 cosine 48. Now, a common mistake that people make is they say 244 minus 240. Well, that's a 4. 4 cosine 48. That's not what you want to do here. The 240 is multiplied by the cosine, so you cannot subtract those two numbers. Do not do that. Once you get to this point, put this in your calculator. 244 minus 240 cosine, oh, and have a 6 there that I don't want, 48. Okay, so I have 83.4 something. So 83 point, I'm going to say 4087. Where's my pen? I forgot what it said. 834087. Okay, now to get C by itself, I'm going to square root both sides. And I'm going to square root like this. I'm going to hit second square root, second answer. I'm doing this to get the most accurate answer I can. I do not like to round until the last step, so we're doing this to get the most accurate answer we can. So our answer is 9.1. Okay, so doing it the way I just did, C is approximately equal to 9.1. Example 4, and this is our last example for lesson 5. We want to find the measure of angle A and round to the nearest degree. You'll notice here that we don't have any angle measures at all. We only have sides. But we're looking for angle A. Remember, you only have one angle in a law of cosines problem. So if I had, for instance, a squared equals b squared plus c squared minus 2bc cosine big A, that's at the end here. So the side that matches the angle, so the same letter, is what goes on the left. So I'm looking for this one. The side that goes with it is 7, because that's opposite. So 7 squared equals B is 5 and C is 8. So just plugging in. Okay. And now we're going to simplify like last time. 7 squared is 49. 5 squared is 25. 8 squared is 64. Minus 2 times 5 times 8 is 80 cosine A. And again, be careful, that 80 belongs to cosine A. Don't touch it. 25 plus 64 is 89. Okay, now our objective is to get this A by itself. To do that, I have to get cosine A by itself. So I'm going to subtract 89 from both sides. And we have negative 40 equals negative 80 cosine A. Now those are multiplied, so we're going to divide both sides by negative 80. Negative 40 divided by negative 80 is 1/2, or 0.5. And you should hopefully remember from lesson 3, the way to undo cosine is with arc cosine. So I'm going to say arc cosine of both sides. So of 1/2, or 0.5, equals arc cosine of cosine of A. So these cancel, and I get, let's see, in my calculator, what happens here. So arc cosine, that's second cosine of 0.5 equals 60. So A is 60 degrees. Okay. And a little summary / cheat sheet for you. This is our last slide. When do I use the law of cosines? Well, when a problem refers to two sides and two angles, because you need to have two sides, two angles to fill in your ratio. So you can see angle 1, side 1, angle 2, side 2. Then you need to use the law of sines. For angle, angle, side, angle, side, angle, and side, side, angle triangles, you will use the law of sines. And again, you're telling this based on the position of what's labeled in your problem. So when to use the law of cosines? You have a problem referring to three sides and one angle, because that's what you need to fill in that formula. So looking at this one again. We have three sides, A, B, and C, and one angle. Then you need to use the law of cosines. If you have a side, 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 like we just had in this problem here, side, 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 no angles given to you, or a side, angle, side triangle, then you'll use the law of cosines. So hopefully this little cheat sheet will help you. Okay. And that is all for lesson 5.